Welcome back to Tune Into Nature. My name is Anna, your host for season 6. This episode is extra special. Not only do we have a very knowledgeable guest, I have some backup as well. I would like everyone to give a warm welcome to my fellow student ambassador, Maggie. Would you like to introduce yourself?
Hi everyone, my name is Maggie and I'll be your co-host for this episode. I use she, her pronouns and I'm originally from St. Paul, Minnesota. I'm a fourth year geology major with a minor in watershed sciences here at Warner College of Natural Resources at Colorado State University.
Yay, thank you for joining us. I'm so excited. All right, so with World Rivers Day being held on the fourth Sunday of every September, we thought it would be a perfect time to highlight a critical natural resource issue, the Colorado River drought crisis.
In today's episode, we are speaking with Brad Udall. Brad serves as a senior water and climate research scientist at Colorado Water Center. He has extensive experience in water and climate policy issues and has authored numerous peer-reviewed publications on water management and climate change. He has also researched water problems on all major southwestern U.S. rivers, including the Rio Grande, Colorado, and Sacramento-San Joaquin.
With that, Brad, would you like to go ahead and introduce yourself?
Anna, Maggie, thanks for having me. So yes, I have the delightful title of Senior Water and Climate Research Scientist and Scholar, which my wife always kids me about, at the Colorado Water Center at CSU. I've been there for 9 years. Previously, I was at the University of Colorado, that other institution down the road, for about 10 years, where I ran something called the Western Water Assessment. While at CU, I was also at the law school, where I ran something called the Getches Wilkinson Center for Natural Resources, Energy, and the Environment, again at the law school. I've devoted my life to water, and as we'll find out, as a kid, I actually went through the Grand Canyon as a 15-year-old, and in college, I worked on water issues as an undergraduate. So it's been a large part of my life, and I'm really happy to be here today.
Yeah, we're really excited for you to join us, so thank you again. To dive right into the meat of our time here, can you briefly introduce yourself and your role as a senior research scientist at the Colorado Center?
So my role at the Water Center involves multiple things. So I do a lot of speaking, believe it or not, in public venues on water issues, especially about the Colorado River. I do a fair bit of writing. I've written multiple peer-reviewed articles on the river and its current situation, including one in 2017 called The Colorado River Hot Drought and Implications for the Future. I spend a lot of time talking to the press, believe it or not, just because the Colorado River in recent years has become front and center in the national scene. And this included, believe it or not, an appearance on CBS's 60 Minutes within the last couple of years, where they did a segment on the Colorado River, believing rightly so that it's an issue of national importance, given that it affects 40 million people in 7 different states and 2 nations and 30 different Indian tribes. So I get to do a lot of different things in my position, and it's mostly fun.
Yeah, that sounds like a really cool and neat position. That is really neat.
Yeah, we'll have to find that 60 Minutes episode. So how did you become involved in researching the Colorado River and the issues surrounding it? Like, what sparked your interest?
So I mentioned this river trip as a kid. As a 15-year-old, my mother took me down the Grand Canyon on a float trip, which is a terrific way to get to see the Grand Canyon and also to sort of get introduced to the Colorado River. Oddly enough, I didn't even want to go on that trip, and she kind of had to force me onto it. It brought home some of my familial background with the river. So on a Grand Canyon trip, you start at a place called Lee's Ferry. Lee's Ferry is below Glen Canyon Dam. It's now the dividing line for the 1922 Colorado River Compact. It was founded by a guy the name of John D. Lee, the ferry was, way back in the 1860s. Turns out John D. Lee's my great-great-grandfather.
No way.
Lee had 21 wives, so it's actually not all that hard to be related to John D. Lee. We kind of laugh a little bit about that. We think maybe he has 800,000 descendants in the American West, although there's
Oh my goodness.
there's no scientific background to that number. I think we just pulled it out of in college, I studied environmental engineering, which involved a fair bit of water resources work. Out of college, I became a consulting engineer at a firm in Boulder, a small firm in Boulder, and we did modeling on the Colorado River, amongst other rivers. And then finally, in about 2003, I took a position at the University of Colorado running a program called the Western Water Assessment, which is and was a $1 million per year research entity designed to connect decision makers with applicable science. And it was funded by NOAA, the big entity that runs the National Weather Service. And that was really my leap into both learning more about climate and getting engaged in the most recent Colorado River issues, which have a heavy dose of climate change on all of them. So, and let me also mention one other little thing that's not insignificant. So after that trip to the Grand Canyon, when I was 15, a few years later in college, I became a Grand Canyon River guide. And that's a terrific way to spend your summers. Trips to the Grand Canyon take 2 weeks long. I was rowing boats, living out of doors, working really hard. You're up, at 5 a.m. and you don't go to bed till 10 p.m. after you've cleaned up all the dishes from the third meal of the day that you've made for people, for your clients. And ultimately, I ended up doing 45 different trips to the Grand Canyon, each 2 weeks long. If you do the math, that's almost 2 years of my time in the bottom of the Grand Canyon over roughly 10 to 15 years. Those 45 trips took. I would do 2 or 3 or early on, even 5 trips a year. So in some ways, between my great-great-grandfather being a Grand Canyon River guide, studying it in school, and then let me mention one other family connection, which is both my uncle and my father were heavily involved in Colorado River development issues in the 1960s and 1970s. So my uncle, the late Stuart Udall, was Secretary of the Interior under Presidents Kennedy and Johnson. And at the time, in the 1960s, development of the Colorado River, building of dams was a really big deal. And he oversaw much of that construction. And at the same time, my father, the late Morris Udall, was a member of the U.S. House of Representatives from Arizona at the time. And he along others, were promoting Colorado River development. And so you'd think I'd sort of planned this somehow to work on Colorado River issues, given all of this background, but it just sort of happened in the way that life kind of unfolds in unusual and unexpected ways.
Yeah, it kind of sounds like the Colorado River is almost kind of like a family business per se. That's neat. I kind of have a similar experience where my dad is also in natural resources. And so I kind of always when I was younger, I didn't know I was gonna go this way, but looking back, it's kind of almost like a little invisible string was tied, connecting things. So I always love stories like that. It's always, I think they're sweet.
That's great. Love to hear it. Yeah, the invisible thread. I never heard that, but it seems like it applies to me too.
Yeah, I can't take credit. It's a Taylor Swift lyric.
Okay, all right. I'll look it up.
All right. So moving right into the Colorado River, could you provide an overview of the current state of the Colorado River and the ongoing drought crisis? And how is this crisis immediately impacting residents of northern Colorado?
So we're now in the midst of a 24-year-long drought on the Colorado River. I happen to think drought is actually not the right term. Drought implies something temporary. And the best science we have tells us what's going on in the river is not temporary. It's in fact a long-term drought, a continuous drought that we're going to see that's occurred because of the warmer planet we now inhabit because of human emissions of greenhouse gases. So in the year 2000, this drought started, and the reservoirs were effectively full. And there are two really important reservoirs in the Colorado River, Lakes Mead and Lakes Powell. They are, interestingly, the two largest reservoirs in the United States. They're enormous. They each hold about 25 million acre feet of water. And an acre foot is 1 foot of water on top of 1 acre. It's a term that comes from farming because farmers think in terms of acres. It's also 325,000 gallons if you want to put it in gallons. It's the size of an Olympic swimming pool. So these two reservoirs, each at 25 million acre feet, hold an unbelievable amount of water, 50 million acre feet combined. The annual flow of the river in the 20th century was around 15 million acre feet. So those two reservoirs control more than 3 times the annual flow of the river. They were full. 5 years later, by 2004, they were half full. We had gone through half of the storage. And no one really knew at the time what was causing this drought. We just knew that these reservoirs were going down quickly and that it was a combination of both too much water use and not enough water coming into the system. Since that time, we've had years with more water and years with less water, but the reservoirs have continued to decline, reaching a low last year of about 25% full. It's important to put this river in context, right? It serves 40 million people in 7 different states. Every major city in the American Southwest has water out of the Colorado River. Front Range of Colorado, here's 50% dependent. Phoenix is roughly about 50% dependent. The Los Angeles area with 25 million people gets 25% of their water out of the system. Las Vegas with 2 million people, 90% of their water comes out of the Colorado River. Even places that seem like they're out of the basin get Colorado River water. So Albuquerque and Santa Fe are heavily reliant on them. And here in the Front Range of Colorado, of course, we're out of the basin too, and it's half our supply. So the crisis it's a really big deal. The science that has gone on since the year 2000 has increasingly pointed to global climate change as a cause, partial or at least partial cause of the decline of flows. The flows are down about 20% in this century relative to last century. And there's good research to tell us that the flows are down because the evaporation that occurs is higher because of higher temperatures. And we think, myself included, and multiple papers have suggested that as it continues to warm, these flows will continue to go down. Not every year is lower, not every year is higher, but the general trend is this declining flows in a process that scientists have termed not drought, but aridification, which is the long-term warming and drying of a particular area. And just last year, with the reservoirs at 25%, the federal government stepped in and said, hey, we need to really rethink how we operate these systems. And there now are 2 processes underway to try and figure out how to remanage the system so we can manage it in a sustainable fashion in the 21st century instead of the unsustainable way we've done it over the last 24 years. So that's at least a kind of postage stamp overview of the crisis. There are many little pieces of this we can talk about, how it affects different entities and people, but the declining reservoirs, the higher temperatures, the lower water flows have all conspired to make it a really challenging situation for everybody who uses the system water.
So you had mentioned that, like, since the planet is warmed, you've been seeing more evaporation out of reservoirs and out of the river, which is impacting the amount of water we have available. And we were wondering, so how have changes in climate and water use affected the assumptions made in the original 1920s compact, since obviously a lot of things have changed in how we use the water and where it's coming from, how much water we have available since the original compact?
Yeah, so before I answer that, let me just make the connection between climate change and changes in the water cycle, because I think it's really important to understand this. And we now have this, we've talked about increased evaporation, but let's talk about some of the other ways that a warmer planet changes the water cycle. So the water cycle is this massive cycle that operates on a planetary scale, and it moves water from the oceans to the continents. It's driven by heat. If you add heat to the planet, as we're now rapidly doing because of human greenhouse gas emissions, you fundamentally alter that water cycle. And we've known this actually since the 1970s and even before. The first global climate models talked about how the water cycle got turbocharged, it got speeded up. And so with extra heat, you get more evaporation, you actually get more precipitation. You get heavier precipitation, and this heavier precipitation is behind the floods we're seeing around the world in many different places, including the Front Range floods here in 2013. In snowmelt environments like we have in the western U.S. and especially the Colorado, all kinds of changes occur. So you get more rain and less snow. You get earlier runoff in the year. You get higher water temperatures because the rivers tend to run lower later in the year. So in every assessment that I have done on climate change, and I've been privileged to work on the national climate assessment that comes out in theory every 4 years, but sometimes it takes a few more years than that. There have been multiple national climate assessments. There are the Intergovernmental Panel on Climate Change Assessments. I've been a co-author on one of those. There are regional assessments, statewide assessment. Every one of the assessments that I've ever done on climate change will have an executive summary. And bullet 3 or 4 out of a 10-bullet executive summary will say, expect major changes in the water cycle. You're going to see more floods and more droughts, more changes in snowmelt systems. As it warms, the atmosphere actually holds more water vapor. So we end up with a sponge above our head that gets bigger. And that bigger sponge can help us both explain more droughts, but it can also explain more floods, because when you go to wring that sponge out, there's more water in there to come down and cause problems. All right, so I just wanted to make it really clear that climate change and change of the water cycle are joined at the hip. And throughout the 21st century, we're going to continue to see these really big shifts in water availability, from too much to too little. All right, so back to your question, how have changes in climate water use affected the assumptions made in the original 1920 compact? So one major assumption is we don't have the water that we assumed was there. So we basically over-allocated the river, thinking that there was going to be plenty of water. And in 1922, no one had any idea. Well, at least a few scientists did, but no policy people understood how climate change was ultimately going to change things. So we allocated too much water. I mean, that's one of the major changes that's wrong. Importantly, the tribes in the basin, and there are 30 of them, and they're guaranteed water based on a really important Supreme Court decision in 1908. They haven't been included in the process for managing and allocating water. And there's still multiple tribes that don't have water rights, believe it or not, 100 years after the compact was signed. So, those are the cities, right, are much, much bigger than they were in 1922. No one envisioned the growth of Phoenix with now 5 million people, or Las Vegas with 2 million people, or several million people along the Front Range, or 20 plus million in LA. Many of the assumptions about supply and about demand no longer hold. And one of the real struggles right now is to try and adjust Western water law to the 21st century, because it's a 19th century creation. It's not just a 20th century, it's a 19th century creation. And frankly, it's kind of inadequate to the task. Let me make a couple points and then I'll stop for a second. So Western water law is based on the idea that first in time means first in right. It's also called prior appropriation. So you have absolute winners and absolute losers under this system of water allocation. And it came out of mining camps and farms in the 19th century. And it was a really easy way to allocate water, right? If you were here first and there's not enough water, we just line up everybody in terms of order when they started using water, and you cut off people who, if there's not enough water, you cut off the junior users until you get down so you can match supply and demand. It's a really, frankly, it's what we have, but it's a really crummy system for an interdependent economy where, unfortunately, because of the way the West got settled, the most senior water rights are agricultural rights, and the most junior rights tend to be municipalities. So we now have a situation where if there's not enough water to go around, as in the case of the Colorado, you'd end up with a silly outcome that 400 farmers in Southern California would get all the water and 5 million people in Phoenix would get nothing. That can't happen. It won't work. And so we're struggling to figure out how to respect the rights of the farmers who were first on scene and have, a legal right to this water, along with the needs of society so that cities actually can have the water they need to perform their various functions and then support the, many, many, many more people that live in them relative to the farmers. So this is just one of many challenges and changes in assumptions that we're trying to deal with now versus 1922 when the compact was put in place, or even in the 1850s and 60s when the first water use in the Colorado River starts to occur in various places, including in Colorado and elsewhere.
Mm-hmm. Yeah, so I'm gathering that adequate policy is something that is really crucial to water rights, and making sure everyone has fair and equal access. And with that 1920s compact, making assumptions that are no longer true. I know we've had work on advising that. So with the 2007 interim guidelines and the 2019 drought contingency plan introduced temporary water allocation cuts. However, what long-term strategies are needed to address climate change and the overuse of water in this region?
Yeah, so briefly, in 2005, I mentioned how the reservoirs had lost half their volume. At that time, the Secretary of Interior, Gil Norton, told the 7 states, she said, you guys have no plan for how to deal with shortages, to how to deal with, not enough water. Either you come up with some or I will. And she gave the states 2 years. And in 2007, we came up with something called the interim guidelines, which implemented some shortages, some delivery cutbacks to various players. And then in 2019, we realized, hey, those don't go far enough. And so something called the Drought Contingency Plan came along. So that's a little bit of history there on those methods to cut back water. One of the issues, too, and this gets back to my prior comments about how our water system has absolute winners and losers and how that can't actually work very well in the 21st century. In the 1960s, the state of Arizona got approved finally after a Supreme Court case that was resolved in 1964, something called the Central Arizona Project. It's this massive 336-mile long canal that takes water from the Colorado River on the Arizona-California border all the way to Phoenix uphill, and then even further uphill to Tucson. So to get the Central Arizona Project through the U.S. Congress, the state of Arizona had to agree to be junior to the state of California. In effect, we had to completely dry up this massive canal that Arizona, including Phoenix and Tucson, were going to rely upon before California would take one drop of shortage. Again, that's a winner-take-all strategy, and it can't possibly work in a 21st century interdependent economy. And that's another one of these cases where we're struggling to figure out how to be both fair to California, which thought it had this agreement, that it was always going to be first, and fair to Arizona, which absolutely needs at least some of this water for Phoenix and Tucson. So one of the strategies here is dealing with these old policy issues that sort of overhang all decisions on the river. And so I mean, I would call fixing that a long-term strategy to address climate change and overuse of water in the region. As part of that fix, we need to figure out how to probably permanently cut back water use, because we have a system that's designed for 15 million acre feet in demands. And since 2000, we've had 12 million acre feet of water. So a difference of about 3 million acre feet per year. And what we've done since the year 2000 to meet that imbalance is empty our reservoirs. But with reservoirs at roughly a third full now, you can't count on that. That just won't work. It works in the short term when you start with full reservoirs. It doesn't work in the long term when the reservoirs get empty. So one of the things we're going to have to do is figure out how to permanently cut back demand. And that probably means buying out some water right holders, which is really expensive. People talk about trying to increase supplies. We may very well end up with some desalination on maybe in Mexico, both on the Pacific coast and Mexico in the Sea of Cortez area. So those are at least two changes that need to go on kind of at the wholesale level. I think we're going to get to rethink outdoor water use just about everywhere. And because outdoor water use, is fully consumptive, meaning you put water on grass, it evaporates, you get nice green grass, that water is removed from the system. Non-consumptive use is use in a household where, you use it in a shower or a toilet or a dishwasher, and it goes back off to the water treatment plant and can be reused somewhere else. It's a very different kind of use, and you can obviously support through reuse a lot more non-consumptive uses than you can consumptive uses. So that's something we're going to need to figure out. We need to figure out how to be fair to the tribes, and that's a real challenge because they actually need water, which means taking water from someone else, which, we're already talking about trying to reduce demand by 1 million acre feet. We may need to reduce it more to be able to provide water to some of these tribes that don't have water. So that's a huge issue as well. Ultimately, I think a lot of it comes down to trying to design a system that's a lot more flexible than the one we have. And while it sounds, nice, it's extremely difficult to do, especially if you're a farmer. And let me wear their hat just for a second, if I can. Farmers tend to have these long-term contracts, right, with people who sell their products. And so while it sounds easy in theory to say, hey, to the farmer, we're going to pay you not to grow stuff and use your water for something else, that can create real problems for farmers because these long-term contracts, their buyers are likely to go somewhere else and say, hey, if you can't supply it, we'll buy it from somebody else and don't come back to us next time because you're unreliable. So it's just really challenging to figure out how to build the system that can deal with varying amounts of quantity from year to year, and also to deal with this Western water law, which is pretty inflexible as designed, but can't work in the 21st century. So, I mean, there's at least some ideas about how to address climate change and overuse. And let me mention one other thing here, because a few years ago, because I talk so much about climate change adaptation, I told myself, I'm never going to talk about climate change adaptation without also talking about climate change greenhouse gas reduction. That at the heart of this, we got to solve this problem of humans emitting too many greenhouse gases. I mean, we can't emit any, basically. And that while not, some people in the water field may think this isn't their responsibility, I'd argue that it is their responsibility. It's everybody's responsibility to figure out how we stop emitting greenhouse gases. And if we do that, then we can help ourselves solve this really difficult problem of how you allocate water, because then we're not going to lose as much to increased evaporation. So it's really important that we all figure out how to do our part, and that includes the federal government taking a big lead in solving greenhouse gas emissions and how we get to net zero emissions of greenhouse gases as soon as we possibly can. So that's at least a thumbnail sketch of how you solve some of these problems.
We mentioned I think you mentioned a couple times now the issues surrounding Lake Mead and Lake Powell and how those water levels have been dropping, which is a large concern for people relying on those two reservoirs. So what are the potential consequences if the water levels in these two reservoirs continue to drop?
Boy, it gets ugly in a hurry.
I bet, yeah.
When Los Angeles, 25% of their water comes out of the Colorado River, if they have a crummy year in the Sierra, as they've had now multiple times, they need that Colorado River water. And again, Phoenix at roughly 50% of water. If they have a crummy year for their local river, the Salt Verde system, they need access. So let me mention something else that's kind of related to this and was a little eye-opening last year. So the Department of Interior, which via the Supreme Court case I previously mentioned in the 1960s, has what some people call the role of the water master in the lower Colorado River Basin. That water master role gives them really large powers to shut water off and to make allocation decisions. The federal government tries not to do this in a heavy-handed way, but I think most people realize that they have real powers if they ever needed to. So last year, when the reservoirs got really, really low, we had a kind of a nice wet winter in 23. And so they're not quite as low now, but the situation really hasn't fundamentally changed. Before this winter, the Department of Interior said, hey, we've got real issues with public health and safety and protection of infrastructure. Two terms that hadn't been used much before in sort of the water management field associated with the Colorado River. And here's what they meant by public health and safety. So in the case of Lake Powell, the little town of Page, Arizona, which I want to say is about 20,000 people, it relies on Lake Powell water levels. And it looked like it might not have any water if Powell continued to drop. And so contrary to what most people thought about how the compact worked and how all these other agreements and Supreme Court cases work, the federal government said, whoa, we got a problem here. Public health and safety comes first. And the town of Page and a local Navajo Indian chapter are at risk of being cut off of water, and we're going to step in and prevent this. It's a little bit like, firefighting in communities. You got to have water to fight fires. And you might not think, under Western water law that comes first, because strict interpretation in many states would tell you, well, that city doesn't get water and that farmer does get water. That, again, can't work. So, and on the protection of infrastructure issue that arose last year that nobody had ever talked about, two things came up. So hydropower in the Colorado River is sort of a secondary use. It's never been considered to be a primary use. It's always, if there's water around, you run it through the turbines and you get the hydropower out, but it comes second. But there's a very large nuclear facility in Phoenix called Palo Verde. There are actually 4 nuclear reactors at Palo Verde. And nuclear reactors require a completely 100% reliable source of electricity in case something bad happens. And in fact, that's why we had problems at Fukushima, believe it or not, or at Chernobyl. If power goes out, you can't take the actions you need to protect the reactors. For years, Glen Canyon Dam has been the 100% reliable source of power for the Palo Verde nuclear power plant in Phoenix. And so part of what Reclamation was saying about protection infrastructure was they wanted the ability to generate hydropower at Glen Canyon Dam so that Palo Verde would have a reliable backup. We were very close last year to losing the ability to generate hydropower because the water in Powell was going to drop below the tubes that supply water to the turbines that generate electricity. So all of a sudden, we've had new issues arise in the basin that nobody ever much thought about. It was always like, oh, these aren't that important, and they come second in the compact and under Western water law. Well, guess what? They can't come second. We've got to protect them. And yet one more of the tricky aspects of trying to come up with solutions that protect uses that we haven't historically much thought about. So there are at least some consequences about water levels in Meade and Powell dropping. And then one other thing I'll just mention, both Meade and Powell are big tourist draws. I mean, they draw millions of people every year to their marinas. People like to do flatwater recreation. And of course, if they drop, the ability to recreate goes down. These big marinas actually get in real trouble because they need to actually stay floating. You can't just dry that. So they actually end up spending millions of dollars pushing these marinas out where they can still float every time the reservoirs drop. So anyway, there's some ideas about the implications of low levels at both Meade and Powell.
Yeah. So some really intense consequences that are going to have some really intense effects on different community members. For those community members, how can states in the Colorado River Basin adapt to changing climate and water availability to kind of help deal with those really intense consequences?
Yeah, so the obvious solution, right, is to use less, figure out how to use less in an equitable way. And every state has their allocation and they jealously guard it. And I understand that. And it's super painful to give up water use, but we're all going to figure out how to use less. This may sound a little bit contrary to what I've been saying or may sound difficult, but one of the things we've discovered in Colorado after forest fires, especially when water quality goes to hell, right? You get massive runoff off of denuded slopes. And for example, the Poudre River turns, black for a few months. Or in the case of Glenwood Canyon, where we had a fire there, water runs off the edges of the canyon, picks up huge amounts of sediment and shuts down both the highway, but also causes real problem for Glenwood's water supplier. What we have discovered under climate change is that cities need not one, but 2 sources of water to be able to diversify their supply in the case that either there's a water quality problem or a water quantity problem with one of their sources. And this obviously goes beyond just the Colorado River, but we need to have robust water supplies for communities. And in most cases, that means having 2 supplies if you're a big enough city and can afford it. And the case with Fort Collins was in the High Park fire in I want to say 2012. They ended up having to use their Colorado River supplies for a number of months because the Poudre River was running black and was completely unsuitable for human consumption. So there's another example there of things we need to do. Um, Figuring out how to conserve, figuring out less outdoor watering is, I think, really important. Multiple sources, being able to share with other communities and figure out how to kind of have interties between communities so that if one community runs out, somebody else can step up and help them survive the short-term needs that they're going to have. So none of this is easy, but it all needs to be done, because what we're seeing in the American West is hotter and drier is our future.
Right. So with all of that in mind, what is your outlook for the future of the Colorado River and the broader water management landscape in the Western U.S.?
So I've produced studies, and other scientists have produced studies that suggest that the 20% decline we've seen since the year 2000, in the worst case, could turn into a 40% decline by mid-century. So 25 years from now, we could see 20% even less water than we have now. Let's hope that's not the case, but we need to be thinking about it for sure. Let me just mention the fire issue. We've seen these fires, and they're here to stay, unfortunately. The Northern Colorado Water Conservancy District, that is an important player in the Front Range. They bring water from Grand Lake under the Continental Divide to the Front Range. They have spent huge sums of money trying to clean up the messes after the Cameron Peak fire, and also the other fire, the name of which eludes me right now, Troublesome. They've literally spent millions of dollars trying to get these watersheds back in a condition where they won't run black when rainfall or snowmelt occurs. We are learning how to do this better. Replanting, for example, in some of these areas where fires occur, mulching is something that the Northern Colorado River Water Conservancy District has done. One other aspect that we don't think about as much here in Colorado is floods. And as I mentioned earlier, climate change is water change. The potential for floods exists. And even though we live in a part of the world where they're perhaps less common, and we always are sort of tending to think of hot and dry, we can't forget about the damage that floods can do. And in 2013, we saw this here, where we got 17 inches of moisture, so a year's supply in 4 days, right about now. It's actually in September, a little earlier in September. And being ready for floods is something we need to do, and making sure our infrastructure is up to the task of dealing with it, and having plans in place so that if we lose critical infrastructure, we can back it up with something else. So, those are some things about what's our outlook and how do we plan for it.
Yeah, you kind of led me perfectly into what my next kind of little topic was going to be, of steps individuals and communities and policymakers can take to contribute to sustainable water management in the region. So you had said like mulching for, that sediment as well. Is there any other ideas that come to you in the moment?
Well, so when I talk about less outdoor water use, it's worth thinking about this for a little bit of a second, because it sounds perhaps easy. It's not so easy. On an individual basis, I ripped out the grass in my yard years ago while my wife did. I shouldn't take credit for this. And she built this lovely xeriscaped garden out there, and it uses a whole lot less water than grass does. So, on an individual level, if you're interested in doing that, that's certainly something useful. In places like Las Vegas and in LA and probably elsewhere too, municipal water suppliers have actually paid people to rip out grass and put in low water landscapes. But if you do that, you got to make sure that, the next homeowner isn't going to come along and put grass back in, because then you've spent a bunch of money on nothing. So, yeah, we need flexible arrangements between farmers and cities so that in times of need, cities can acquire water from farmers in a way that's at least, minimizes the long-term harm. We've been thinking about plans like that for years. There's always room for more innovations in that. Western water law continues to need to be modified to kind of move it in the 21st century so that, we do what we can to protect our environment, and yet make it flexible so that in times of real change, it can adjust to new needs.
Yeah, I think the lawn thing is really interesting and a really cool incentive that a lot of governments are doing. I've seen a lot. It's a little different, but I've seen a lot of native lawns here, and just Fort Collins. And if I had a lawn, I think I would be all up in that business. Yeah.
It makes me wonder.
Go ahead.
Oh, it just makes me wonder if that's something we can write into more than just incentives for residents, if we can make that almost a new law for local communities, since you mentioned that issue of one resident could put in a low water use garden, but then what happens when the next homeowner comes in? How are they going to change things?
Yeah. No, we need changes in codes, for example, so that we get good water use. In Las Vegas, I think they basically outlawed front lawns because front lawns never get used. I mean, they're just ornamental in houses. If a piece of grass doesn't ever see a human foot, it shouldn't be there, right? Grass in street medians is just a dumb use of water because you end up watering concrete mostly, and it never sees a human foot. So, and outdoor water use is about 50% of water use in the American West, believe it or not. And again, it's fully consumptive, so you don't get a chance to reuse it. There's actually a lot we can do without outdoor use. The one thing I will tell you is that trees make cities really livable, and we can't give up on trees. Trees, obviously provide huge amounts of shade. They keep temperatures down. They fight the heat island effect, of dark asphalt or concrete. So trees are really valuable, and we need to figure out how to water them in this new world and encourage more of them. But less grass is almost always a winner.
Sorry.
You're good. Take it from the top.
How can current students interested in this work get involved?
Yeah, so, the thing I would tell you is water is going to be a big deal in the 21st century. It already is. Again, this climate change is water change will continue to haunt us. There will be a lot of economic opportunities to figure out how to use water better. And so as a student, it's hard to think about exact ways to get students involved, but it's not hard at all to think about students who are graduates being involved in this, because there will be and are enormous opportunities in water providers and non-governmental organizations that work on the sidelines of this. The feds have a big presence in Colorado River issues and do a lot of technical modeling. And then local water providers, because of the big baby boom retirement issues, there are lots of opportunities here. And I would encourage students to, really understand, do what coursework you can on climate change, especially understand the water cycle. CSU has a tremendous number of faculty that work on water problems, something like 200. And they're just all kinds of different aspects to water, right? Groundwater, surface water, water quality, water quantity, ag water use, city water use. You name it, there's enough for multiple lifetimes of work if you're interested in water at all. And it's just obviously such a critical substance. and it is going to become more so as the planet warms.
Yeah. Well, thank you. We have a really big little, well, I don't know if I would say big, but we have a very mighty force of watershed science students here, otherly called the shed heads. And so I think they'll really find this really interesting.
They'll be taking it on.
Yeah. Yeah. All right. So it looks like we only have around 4 minutes left for this recording. But to wrap us up and get us going, we have a couple rapid fire questions for you. The first being your favorite water-based activity.
So I'm a whitewater kayaker, and if I could be anywhere, I'd be in my kayak, my hard-shelled kayak, in some rapids somewhere, or even flat water, but rapids are especially fun. So there you go.
Yeah, that makes sense with your history in the Grand Canyon. So yeah. Favorite body of water?
I would say any free-flowing river is my favorite body of water. I love all free-flowing rivers. There's something magical about being near a river. And there are tons around. You can find one in your community.
You might have already answered this question, but lakes, rivers, or the ocean?
Mostly rivers. Natural lakes I love. I'm not as inspired by reservoirs, even though they're certainly important. In recent years, I've actually had the opportunity to do a bunch of sea kayaking with my brother in the Gulf of California, including paddling across the Gulf last year, 60 miles over multiple days, hopping from island to island. So, I like them all because of my river background. I'm a little partial there, but I've grown to appreciate water, both salt and fresh and free flowing and stationary in all its forms.
That sounds like an amazing time. Oh my goodness. That's cool. All right, one last rapid fire question and then we'll wrap up. But what is your favorite water-based creature?
I'm a little partial to mammals that live in water, so otters and beavers. And you may be aware, people have gotten really interested in beavers recently as supplying necessary ecosystem services. Those dams they build in high elevation places are really good. They actually sort of create a big sponge up there that then slowly releases water through the years. So who doesn't like an otter in a river?
Yeah, a keystone species will never do you wrong.
Yeah.
All right, well, we want to thank Mr. Brad Udall so much for joining us today. Your insight was absolutely incredible, so thank you.
Thank you, Anna. Thank you. Go ahead.
Thank you. That's all we have for this episode of Tune Into Nature. Tune in next time for a haunting tale of forest disturbances in our Halloween edition.
We'll see you next time
on Tune Into Nature.